Suppose we have a pond and the pond is full of fish, and we're trying to investigate this population of fish, which means a very basic question to ask is the size of this population. So how many fish there are in the pond. Now clearly in real life we can't literally catch or count every single fish, so we concede that we won't be entirely accurate, but there is a method using sort of ratio and proportion to get a decent estimate. The idea is this: we go fishing and try to catch a decent number of fish from the pond. We then do something called tagging the fish we've caught so we can tell the difference between these ones and the rest of the population. In practice, this often involves physically attaching a tag to the fish or something, which is why we call it tagging. But yes, they are careful not to harm the animal in the process. For the purposes of this video though, we will simulate tagging by simply colouring the fish red. At this point, it's good to know exactly how many fish we've tagged, so in this first fishing trip, we happen to have caught and now tagged 20 fish. It doesn't have to be 20, it's just the number we happened to catch on this first fishing trip. What we now do is we release all these tagged fish back into the pond, and then we wait. Now the timing's pretty important. It's got to be long enough for the tagged fish to spread themselves out more or less evenly within the pond, but not so long that the population drastically changes in this window of time. Now after this time, we go for a second fishing trip and just catch whatever, hoping we get a nice mixture of tagged and untagged fish. So let's say in this case we caught a total of 36 fish, 8 of which were tagged. Now here, the key idea is that we assume that the fraction of tagged fish in our sample from our second fishing trip accurately reflects the real fraction of tagged fish in the entire population. Now we know it's incredibly unlikely to be actually correct, but we assume it's close, so we will base our estimate on this assumption here. More precisely, it means we should think about comparing the total number of fish to the number of tagged fish in both the sample and the entire population. It doesn't really matter which way the fraction goes, so long as we keep it consistent which way we're comparing the two numbers, but the algebra just works out nicer if the number we're trying to find, which is really the total number of fish in the pond in this case, is upstairs in the comparison. So first, we might look at our sample, or the fish we caught on the second fishing trip. The total here is 36 fish caught, and from there we found that 8 were tagged, so we write the fraction 36 over 8. But now if we think back to the first fishing trip, we know exactly how many fish are tagged in the entire pond in total. It's 20. So if we zoom out to look across the entire pond, then we can write down a fraction where upstairs we have the total number of fish in the entire pond, which was our goal, and downstairs we have the number of tagged fish in the entire pond, which we know is 20, because that's how many we caught on our first trip. So if we just ignore the middleman for a second, this gives us a pretty simple equation to solve to approximate the total number of fish in the pond. We just need to get rid of the divide by 20 on the left-hand side, and we can do that by multiplying both sides by 20. So our guess would be 36 over 8 times 20, which gives us 90 as our final estimate. So this is a technique called capture-recapture, named after the two fishing trips, although in practice researchers often do more than two. This question is actually exactly a past paper question already, so we might just leave it here for now. Okay, the main idea is to base your calculations off this assumption that the fraction of tagged fish in your sample accurately reflects the fraction of tagged fish in the entire population. Then by writing out those two fractions, comparing the total fish with the tagged fish, we get a pretty simple equation to solve for our estimate. So that's all for this one. Thanks for watching. See you next time.